Okay, and hopefully everything is up and running. I think my microphone is a little bit low. Let's just try it like this. That should be better. Okay. So, okay, let me just double check this, if this is all correctly set up. Okay, looks correct. Right. So this weekend will be interesting. So last weekend I kind of already dipped into this topic. So it turns out that my lovely favorite language, C++, kind of has this interesting blind spot where it comes to HTTP client code. So there are definitely libraries for, HTTP clients, but what's completely missing, at least it looks like so far, is a lot of the more complicated stuff. Like, there is specifically a Microsoft library, it was, what the heck was the name of it again? CPP REST SDK, right? Yeah, so there's this library that would be kind of perfect. However, it turns out this library isn't like super well supported anymore, and I was even told like straight up by one of the devs not to use it. So yeah, turns out that I kind of need to learn JavaScript, I guess, if I want to do, client level stuff. So that's kind of the goal. The JavaScript that I want to kind of learn is essentially Node.js stuff and TypeScript, that kind of style, and honestly mainly kind of stuff you can run on the command line. Essentially, just like plain code, not really any web browser stuff. But I'm kind of hoping that's kind of transferable. So I didn't really do any preparation at all for this. It's really like I know certain things, but I'm mostly going into this completely blind. And to kind of, if you are here for the first time, to kind of understand my level of craziness, just to show you this thing, which is, just a like HTML UI thingy. This is all done in C++, and not like a server running rendering this stuff. No, this is C++ running in your browser. This is all ASM.js. So this is kind of the level of craziness I'm willing to go to kind of not use JavaScript, at least, until now. So yeah, like this is kind of my like last resort, level of, thinking. I really need to start learning JavaScript because there's no other option, essentially. Okay. So I did some Googling. So there's this website, Typescript documentation. I think the TypeScript for Java C# programmers might be applicable to me, I guess. TypeScript tooling in 5 minutes, that sounds good. Yeah, okay. Then there's like a bunch of things. Okay. Yeah, okay, so this will be, let me just make it slightly smaller. This will definitely be useful. So let's just pin that. Let's see. Yeah, this I might already have, but let's just double check. Cool. Yeah, okay, so this is actually running. Document.body, so I guess this is for the browser then. Okay, if I just take this. And I guess console.log something like this. Node.js. Okay, yeah, so this actually works. Cool. Okay, so the compile actually, I guess, is checking for the type annotations in TypeScript, I guess. Because so this says it takes the TypeScript and generates the JavaScript. Cool. So I guess I can just try it. Yeah, so this did generate. Okay. Okay, so now this file is conflicting with my hello.ts. Interesting. Okay. Okay, let's make it a string, sure. Will this still run as it is, or do I need to do... No, it will not run straight up. Okay, maybe a little bit of syntax, but... Yeah, no, okay, so the problem is, if I run it as Node.js, it's actually interpreting it as pure JavaScript. So, I mean, okay, let's look up how do you do this stuff. So, I guess TypeScript, Visual Studio Code. Okay, so there's okay, right, so we add this thing as the project. Wait, so what was the name? tsconfig.json. tsconfig.json. Right. In the current folders. Right. Definitely want to put it into different directory. Let's just make a directory build. Now the question is, will this actually create a directory? Nope. Interesting. Well, okay, let's just make the directory manually. Maybe it's... There are two options, like either it's completely ignoring the settings, or... Yeah, it looks like it's completely ignoring the settings. So... Okay. The compiler knows to look at your tsconfig.json. Well, apparently not. Yeah, I don't think I have a typo in the file name, but let's just... Yeah, no, the file name is correct. So then, why does this thing ignore it? I'm not quite sure. Interesting. I mean, I feel like I have exactly what I should have. It's just not getting picked up. Okay, let's see. TSC ignoring tsconfig. When input files are specified on the command line, okay. But then, okay, wait a second. So you specify the files in the tsconfig somehow, or it just like does all the files? Right, so this actually has an exclude, so I would expect it to just like do everything. Okay, so let's just do tsc then. Ah, yes. Okay, so that was the problem. So if you run it manually, I mean, if you manually specify the files to compile, it will actually ignore the tsconfig. Okay. You know what? Actually, let's just start writing these notes down, which is... This might be useful to some people at some point. Okay. So... Typescript compile. Okay, let's just make this like this. Okay. If files are manually specified for the TypeScript compiler. It will ignore the tsconfig.json file. Okay, cool. I don't actually want a split editor. Is there a way to like view the preview of Markdown? Maybe not. Yeah, okay, I can live with this. So, okay, so that's one thing. So we are building into a directory. Cool. If I numbered right. Okay, sure. Let's test this then. So if we have let message, what was the syntax again? Okay, so it's always a colon and a type. Right, and now it's saying number is not assignable to a string. Okay, cool. That works. Why is all of this indented like that? That's weird. Okay. Unreachable code. Sure. TypeScript debugging. Sure, let's turn it on. Why the heck would we not? Okay, let's quickly see. So I have done that. Start debugging in Node.js. Okay, so this just run. Okay, so let's actually start again now with breakpoints. Okay. So we have breakpoints. Okay, so yeah, sure. So it's pretty normal. We have the local variables. We can add watches. We have the call stack. And the breakpoints down here. And okay, so up here is the step over, step into, and so on. Okay. No, cool. This looks pretty normal, all things considering. Yep. Compiling. I mean, one thing is I would kind of like to have like a very simple way. May TypeScript build a default. Config. Okay. Configure tasks. From template. No. Wait, what? Configure default build task. Ah, this one, right. Okay, yes, so default is TypeScript, okay. And then Control Shift B. Right, okay. Let's just delete the build for just delete the build and try again. So this should, yep, it did. Okay, so it's Ctrl-Shift-B is my build. Now the question is, can I do something similar for the like running stuff? Like how do I configure the run command? Okay, there's debugging. Run active file. Okay, what exactly will that do? Run active file. Only files on this can be run in terminal. What? Okay, that's a bit confusing message. Only files on this can be run into terminal. Yeah, so the thing, like the part I'm not super keen on is run without debugging. No, I don't think this is what I want to do. Yeah, I'm not quite sure if there is a way to just Oh wait, now it did stuff. I'm getting a bit confused. Why did it rebuild? It's rebuilding stuff. Yeah, like okay, so it does actually run it in Node now, which is good. The thing I'm not super thrilled with is if I press Ctrl F5, it will basically switch to this task over here, and then the output is in the debug console. But okay, I guess I can live with that. It's not too bad. Okay, so I guess that would be the TypeScript setup. So we do have, I guess, the basic setup for TypeScript. So now I can actually look at coding stuff. Okay. Right. Okay. I'm wondering if this tutorial will be a good tutorial to go through. Okay, so they're talking about the type system over here. So yeah, I mean, this also applies to C++. Every object has a specific value, right? And if you have like dynamic types, all that's happening there is that you basically have object that can like contains or is contained within other objects. So it can kind of stand in, you know, by providing like a subset of itself to work as the other type, but it doesn't really change what the like entire blob in memory, like what its type is. So I kind of expect that arithmetic, not their structures. Yeah, I mean, so far that I know about JavaScript is, I think that's more in line with like interface-based typing, as in like if something conforms to an interface, then it is of that type, like irrespective of what the actual type of the object is. I guess it's actually kind of like Go is in that way. Like in Go, you kind of can say that the function takes anything that satisfies an interface, and then it doesn't really matter what the actual object is, as long as it provides the specific methods that the interface is requiring. That's good enough. Because types are just sets, a particular value can belong to many sets at the same time. Sure. Okay. I mean, this part is weird to me. So they're basically saying that like you can have a type that's both a string and a number. I mean, from the type system perspective, this is very natural, but from like the okay, so I guess what I'm not sure about here is like, are they just talking about the type system itself, or is this also like, is this kind of like, are they talking about the equivalence of C++ union, as in you have something that's either X or Y, either a string or a number, or is it actually like a union in the type sense? Like, would this be like something that at the same time behaves as a number and a string? Or is it just a thing that can either be a string or a number? Like from this, yeah, I don't know, like it's slightly weirdly formulated, so I'm not quite sure. Okay, objects are not of a single exact type, sure. Yes, so if we construct an object that satisfies an interface, we can use the, yeah, okay, so this is very much the interface style of typing for objects, which is very easy to understand. Basically, you have an interface that describes what an object should look like, although in other languages like in Go, it's usually about the methods, not necessarily about the like attributes. I don't, can you actually do that? I don't. I actually have to admit I'm not sure, but I think you can only talk about methods in Go in your interfaces. But yeah, like, you know, it's like that very typical. If I go back to here, okay, let's write down nodes because that's a good idea. So. TypeScript nodes. So the type system interface based types, objects that satisfy an interface are of that type. Unlike Go, interfaces can include attributes, not just methods. Okay, so yeah, I mean, here we have point like, which is like two numbers, so then anything that has xy in it can be passed into this thing. I mean, this is almost like, I think this was kind of the idea that the C++20 what the hell is it called? There's like the type concepts, C++20 concepts. I mean, these are of course static completely, right? But yeah, so you have a function that takes a t and t is hashable. So if you try to pass in something that isn't hashable, this will not compile. And I actually like, this is okay, so this is actually very similar, right? Because since this is TypeScript and you actually compile TypeScript, I assume this actually gets checked when you are compiling. I mean, at least I would expect this to be checked when you are compiling the TypeScript into JavaScript. Right. Yeah, so this is a very similar idea to concepts. So the thing is, I'm not. Yeah, and you can have conjunctions, disjunctions, and atomic constraints. So I'm not quite sure if you can refer to attributes again, because that's one thing about the TypeScript that's really weird to me, because I'm trying to think what other language has that. But usually when you talk about interfaces, you always just talk about the methods. You never really talk about the attributes, because that's kind of considered something that you should not be exposing usually. Like, that should be kind of your private stuff that you then wrap into methods, and then those methods are the interface. But it's interesting, like it's an interesting idea, because I mean, technically yes, like if you have just a struct, like why would you not have an interface for a struct that just says, hey, this struct has to have an x and a y? Okay, actually, let me just copy this because I'm quite curious what happens if I break some things. So let's just write this down. So let's go to our file. And what was it? Control F5. Yep, okay. Yeah, so we have print point that takes a point like. So okay, so what happens if I just do Z over here? Okay, argument of type Z number, Y number, name string is not assignable to point like because it's missing X. Okay, perfect. So this is working exactly as I would expect. Yeah, it's just slightly weird that we can refer to attributes. That's really the only thing that's kind of throwing me off. Otherwise, this is very normal, let's just put it that way. Right, and naturally, because this thing has both name and XY, then it kind of satisfies both the point like and named interfaces, so it can be passing to both of these things. Yeah, okay. Yeah, so it's very implicit. Again, like the moment something satisfies certain interface by just its structure, it's of that interface. Okay. What is actually reified? I don't even know what that word means. Make something abstract more concrete or real. Okay, so what does that mean in this context? I mean, they're just saying that this is purely during the compile time. I'm not quite sure how that makes it abstract. It just makes it compile time. But maybe I'm missing something here, but sure. Okay, going back to the idea. And yes, okay, because it satisfies both of those interfaces, then it's of those interfaces. Okay. Empty types. Sure. I mean, okay, so yeah, so I don't know if this is surprising. Like, to me it's not surprising. It's just if you have an interface that's not putting any expectations, then like something that provides more, like there's no negative way of saying that, like in the interface this doesn't have something, right? Yeah. Yeah, I mean, I guess some people might find this surprising, but it's, I mean, it's about the interface is about the expectations. So like if, you know, the moment you satisfy all the expectations, then you are of that type. Yeah, and if you have multiple interfaces of that kind of are the same, they are the same. Again, this I don't really find surprising. Being able to query the type of any value, even a generic one. Right, okay, so this is okay, so this goes back, it's just a compile time, there's nothing runtime that remains in the JavaScript, in the generated JavaScript itself. Right, okay, sure. Through the handbook, okay. Okay, so I mean that was actually a very nice intro to the like basics of the TypeScript type system. But now the question is, where do I go from here? Sure, I guess let's just go through this step by step. Okay, so we have booleans, sure. Let's just play with this. If I do this, yep, it complains because this is not a boolean. Okay, perfect. I wonder though, so are there any... Yeah, they don't really talk about it here. So in C++ you get this default conversions from numbers to booleans and from booleans to numbers, which is quite useful usually. So I wonder if something like that exists here. All numbers in TypeScript are either floating point or big integers. Okay. Okay, so if okay. So this floating point get the big integer. Okay, so from this description I'm actually a little bit confused. I'm not quite sure. So I mean, if I write this, does it end up as a float? I guess what I'm asking is if I do something this, right? What is it complaining about? Wait, so it needs to do... Oh, okay. So, wait. So, multiple questions now. First of all, where the heck do I specify what JavaScript I'm targeting? Okay, let's... What version of JavaScript am I targeting? But this error is telling me that, so if I just write 10, this return is of a type number, because that's the error I see here. So it's telling me that a number is not assignable to big int, which honestly that's a... So does it really mean that the TypeScript type system is so rigid? It's probably something like this, right? No? No, probably not. I mean, there needs to be some sort of like cross-typing support, but or like type conversion support, but yeah, like this basic, like, even though, from what they are saying here, it kind of sounds like a number yeah, okay, this part confuses me. Okay, let's just put it down as a question. Because like this almost sounds like basically all numbers are floating points, unless you are targeting the, you know, ECMAScript 2020, at which point you can have big int literals which are actually integers. Could be something that has to do with JavaScript, honestly. I'm not quite sure. Okay, let's just keep that as a question and let's move on. Okay, a string. Okay, so either double quotes or single quotes, and each string is a string. Template strings. Okay. So okay, you just refer. You can have embedded expressions. Okay, cool. Yep. Okay. So let's just put this down here. Yeah. Okay. Now this. So console.log. And it was Control F5 to run it. Yep. Cool. This is pretty reasonably nice. Even like one kind of awkward thing is if this gets too long. I mean, these expressions can get quite awkward, which is kind of the one benefit of having formatting where you have placeholders, because then it doesn't really balloon the string itself. Because, I mean, technically this can be any expression, right? Like, so this can be like a call to a function, you know, through an object dot something, whatever, you know. So this can very naturally get quite long. So I wonder if there is a way to have like placeholders in here and then just do like something like dot format, and you know, you just pass in whatever you want to pass in. But yeah, this is not the worst, for sure. Is equivalent to the current sentence, like, yeah, okay, sure. This is the very much a C style. Okay, but good to know. So you need to actually do plus. You cannot just have continued string literals after each other. Okay. Array. Okay. Well, what I would like to know is if these two things are exactly the same, because they say you can do it this way or this way, but now is there any difference? So if I do something like this, and it looks like I'm getting methods that I would expect to have on an array. I guess we can... Does this work? Yeah, okay, so I guess they're the same. And I guess we can double check by doing it the other way around. Oh, hey, welcome. Thanks for the follow. So yeah, I guess these are just different syntaxes for the same thing. Tuples. String and a number. Yeah, okay, so this is just straight up tuple. The syntax is a little bit funky. Hey, welcome. And justify the delay on YouTube tends to be absolutely crazy. So yeah, don't get like discouraged. Especially if you have the like recoding turned on and not if you are not watching it in the original quality. I know that the like delay can be up to multiple minutes. And unfortunately I cannot do anything about that. Right. So yeah, I don't know how I feel about this syntax. Mainly because I'm super used to like something like this. I would basically write this kind of stuff, right? It's a bit weird that it's using kind of the right angle brackets for tuples, but yeah, okay, I mean, so this actually needs to always be initialized with the precise number of elements, right? So if I just do this, this will complain that it's missing one of the elements. Come on. Yeah, because this is the, like, okay, it's a uniquely different tuple, so a string and a number is different than string, number, string. Okay, cool. Now it makes sense. Like, weirdly enough, the TypeScript's like type system itself actually seems to work kind of similar to C++. Like, I'm finding a lot of like equivalent behavior. Right. When accessing an element with a known index, wait a second. So this is still indexed. Ah. So this is like, you can basically do a get, but use the like plain array access. Like if I do x1, that should be a number. Yep, okay. And this will complain because now it's a string, right? Yes, okay. Phew, okay, I mean, this will take me a while to get used to. Like specifically this syntax is very funky for me. Like this is definitely not something I'm used to. But yeah, like in C++ you would basically do like, this would be a tuple, right? So this would be like I don't know, std tuple, std string, int std string, something like this, and then you would do x get 0 to get at like the 0th element. It's kind of because, you know, this is a template, then you are kind of getting, like, you need to use the templated stuff. So it's actually, yeah, like a lot more awkward in C++ because it's, you're interacting with these two layers always, which kind of is also happening here, but the TypeScript, I guess the difference is like the TypeScript is kind of hiding JavaScript from you. So in C++ you kind of get this layer of the meta type system on top of the language. So you always like are touching both at any point, because I mean that's how it works, right? In TypeScript, like you kind of get this like a completely new view of the language, which then like compiles into JavaScript, which is kind of interesting. Like it's the thing, of course, in C++ is like all of this, like both the meta language and the language itself are compiled, so there's no difference. The difference here is that the TypeScript is compiled, but JavaScript is dynamic. So okay, yeah, I mean this part, this will definitely take me a while to get used to, but because the syntax is super funky, but I mean I do understand what's happening. And yes, obviously if you try to access something that's outside of the bounds, yep, okay, enum. Okay, so this is actually this is where it gets interesting. Yes, so enums are numbered, but what I wonder is, well, so tuple is just a fixed length array. It doesn't really work from the perspective of a language like C++, because in like strongly typed languages you don't have arrays that have different elements in them. Like an array is an array of the same type. So I mean yes, like I kind of understand what's happening here. It's just like the reason why it's weirding me out is because it's very like it makes total sense in the context of JavaScript. It's just weird from the perspective of a typed language like C++. Okay. One thing that I want to see immediately, and probably they're talking about it later, I actually want to see this kind of stuff. Okay, so oh, I already have X, so this is okay, so this works. I was really wondering if this will work. Okay, so this is interesting. This is very interesting. So yeah, so the enum, so basically the elements of an enum are numbers. Okay. So you get the back mapping. Wait, you also get it as strings. That's interesting. So yeah, if I do okay. Boom. So this returns a string, I guess, and these are numbers. Okay, it's interesting. I mean, to be fair, honestly, like whenever I have enums in C++, like this is exactly what I do. But you kind of need to build this for yourself in C++. In C++, you would have an array of strings next to this, and you just make the things match up. Or if you have like a sparse numbering, you would have a switch that handles that. Okay. Okay, so unknown is kind of a variant thing. It can basically be anything. Unknown type, you can nerf it type of. Okay, wait a second. Now I'm a bit confused. Ah. Wait, what? Okay, this section just like I'm totally lost. Okay, so an unknown is basically anything, but then what's wrong with this? Is it just the problem that we are assigning directly to a number? Okay, I missed the... Right, okay, now I get it. So here is just comparing the value. Wait, this is a JavaScript thing. What is... Yeah, what's the comparison stuff here? So equal... Okay, right, so I guess equal value, and this is equal value and equal type. Okay, so I guess this is saying, where was I? Yeah, this window. So if I write, maybe true, I'm saying that maybe is of type boolean and also value true. So it's kind of equivalent to like type of maybe is boolean. Okay, and maybe true. Yeah, that should be it. Okay, and then I can do not equal and not equal value or not equal type. Okay. Sure. Right, so then I kind of understand what's happening here, because like we kind of, in this branch, we know for sure that it's boolean. So this is suddenly allowed, because we know that maybe is of type boolean. This assignment here isn't allowed because we don't know anything. And this one is also not allowed because we know this boolean, so we cannot assign it to a string. Okay, makes sense. And the same idea here, we know that it's a string, so then, okay, sure. Okay. Okay, so any is like, yeah, so it's basically unknown, but without the type checking, in cases where we actually figured out something. Or I guess any will actually allow me to do this kind of stuff, what was basically, okay, so if I make this any, then maybe equals 2, because it's a constant. Okay, sure. It was the other way around, right? Like it was let I number equals maybe, yeah, okay. So now this doesn't complain because any literally means like, yeah, it means it's unknown, but actually do allow anything. Okay. Makes sense, makes sense. Right. So yeah, okay, so this is the example exactly I was talking about. So on an unknown, yeah, this will not work because we need to first figure out the actual type. We basically need to check if it has an interface that actually has the 2 fixed. Although this is weird because I would kind of expect, like, since we assign a number into it, I would kind of expect this to be in the this is a number context. But yeah, I mean, here it just passes because it's any. Okay. Through your objects. Yeah, okay. Yeah, if you get anything out of an any, it's also an any. Makes sense. And void is a void. Okay. Okay, null and undefined. Okay. So where do you actually specify this strict null checks? Because I'm using the tsconfig.json, so can I just do strict true? Okay, sure, let's do it. Okay. Okay, I kind of... This is a weird type. Like, I'm trying to think, like, is there... Yeah, there's like nothing equivalent to this in C++. Because, I mean, you would just return void. Because the thing is, like, this is like, this is not really a type, this is kind of... Like, this is kind of annotating code that should never be accessed. So it's a, to me, it's a little bit out of place in the type system. Because it's not really a type. It's interesting, like it's... I guess this is the important part, like you can basically narrow down... But by any type cars, that can never be true. Interesting, like... It's a very curious thing to have in the language. Okay. Sure, objects are objects. Makes sense. Yeah, okay, we just cannot assign the basic types into it. Makes sense. Yeah, I'm. You will need to. Yeah, it's. I think this is really for like low-level libraries, because I mean we should be always talking about the interfaces, right? Like you never take an object, you take a specific interface. Like taking an object is way too generic of a thing. Okay. Okay, so this, yeah, okay, so this is the very typical casting, essentially, that you would get in C++. Okay, right, so yeah, I guess this is on, like, this is the example how to get at it, because you kind of need something that's not of that type and then just say, yeah, whatever, I know what I'm doing, this is definitely a string. I mean, this would mostly happen if we have like a flow through thing where like I pass something into a function and I know that basically the function returns whatever it takes. Then I can basically do, you know, the return as whatever I passed in, because I kind of expect then the function would basically be something, you know, how do you do it? Declare, so there's an example up here, and declare function so this, you know, takes I guess unknown and returns unknown. Yeah, something like this, and then basically you know, something like this. Okay, yeah, no, this makes sense. So okay, the syntax is something as a type, and then it's typecasted. Okay, sure. So far they've been using let keyword instead of var. Let and const fix a lot of, sure. Number, string, boolean, symbol, or object. Right, so in TypeScript always use the lowercase. Okay, sure, I can do that, makes sense. Okay, interfaces. Actually, let me take a short break. Yeah, so far this is kind of making all sense. Nothing. There are some couple of surprising things. The stuff around maybe is a bit unusual. The tuples have a bit of an unusual syntax. The enums are also kind of not super unusual, but yeah, it's kind of like three things wrapped into one thing. Like the enum is the enum with these things, but then it also provides the strings, these strings, and the numbers. So it's a little bit funky, but yeah. Okay, cool. I will be back in 5 minutes. Okay, and I'm back. So okay, this is actually looping, so let's try the next thing. Okay. Okay, this is interesting. So we literally can specify the interface inline. That's actually quite convenient, I have to say. Yeah, okay, let's just was there anything that I wanted to make notes about? So okay, formatting strings, okay, it's one thing that definitely will come useful. Okay, this question I wanted to leave up here that I wanted to revisit. Right. Tuples are similar to C++ template magic, but instead work like arrays indexed directly. Okay, sure, that makes sense. Right, this thing I definitely want to make note of. So enum elements of an enum have values of type number, and enum is indexed for accessing the labels strings. Okay, cool. So that's this part. Right. So unknown for a typed variant, any for an untyped variant. Okay, cool. Okay. Oh, no, not this. I wanted to copy this example. Right. Okay, and run it. Size 10 object, right. Okay, so labeled object. Okay, it's literally. This is pretty neat. I do like this. I'm trying to remember, like, if you can do this in Go. I think in Go you need to define a separate interface. Although, honestly, I don't remember. Yeah, and we can make it explicit. Sure, that makes sense. Labeled value, yeah. Okay. That all makes sense to me. Okay, optional. Oh, wow. This is new. Okay. This is something unusual for sure for like static languages. I don't think I have seen this ever before. Like having interfaces with optional fields. Yeah, I really don't think I have seen this before. This is interesting. Okay, so this is taking the square config, then returning color and the area, right? So we have like a default value, and then if config.color. Okay. Very interesting. I guess this is also telling me basically. Can I do console log my square? What will that do? Yeah, okay, that worked. So yeah, so it filled in the area. Makes sense. So this is interesting because this is basically yeah, okay, so it's either a string or undefined. Okay. So is this checking for undefined? So I guess what I'm asking is this equivalent to this? Actually, I guess this? No, the negative, right? Is this the equivalent formulation? If this is not if this is not undefined, then do that. Did they talk about that? Okay. No, they don't really talk about it. Interesting. I would really like to know what's happening here. Because, I mean, obviously the if works with the boolean, right? Like, where's the boolean coming from? Is there... Okay, I really want to know more. So... optional properties. So, TypeScript optional properties. Transferring options require... Okay. Yeah, okay, this is talking about something slightly different. Yeah, okay, let's just put it down as a question. So the question is, okay, I guess I should just create a questions section down here. So, okay, the first question was, right. Yeah, thanks for the help. I mean, but that's actually the part I'm not clear on. So when does the what can be coerced and how does that exactly work? Because so far I haven't figured out how, you know, how exactly does that work. Okay, so what was my question over here? I already forgot. Right. The question here was, are all number literals floats? Okay, and then this question is, what is actually happening when checking for presence of optional what is it called, optional property, right? is it equivalent to if not property undefined? Yeah, I think that was the question there. Am I right? Yes. Okay. I mean, yeah, like the basic question I have is if, you know, the if is equivalent to this expression, or if there's some more magic happening somewhere. Right. Okay, read-only properties. Okay, sure, this is a bit weird, because why would you have a different, like, why would you have a explicit keyword for this? Why not just use const? Yeah, okay, so this is a return whether use reason only is to ask whether you are using it on a variable or a property. Yeah, okay. Like, this is really weird. Like, I don't understand why you would make this distinction. Like, I don't really see why you would invent another keyword. Maybe there's some technical reason for this, but yeah. But sure, okay, I can just remember that read-only. What the heck is that music? Okay, that's extremely weird music. Let's switch to something else. Okay, yeah, I can just remember that I need to use read-only for properties and const for variables. That's fine. Access property checks. Okay, interesting. Argument of type color width is not assignable. Object literal may only specify known properties, but color does not exist in type square config. Square config. Okay, so specifically for object literals, it will also check for access properties. Okay, that's interesting. I guess it kind of makes sense because you are calling a function and you know what the function, like what type the function is taking. So then it would be weird to specify extra things in there, I guess. Like it's, yeah. And I guess that also applies to like creating an object of a specific type. Interesting. Yeah, and square config, sure. Yeah, makes sense. Oh, wow. Okay, what? A string index signature. Okay. Yeah, we are getting into the magic parts of this language for sure. Okay, but I expect, so if I do, where the heck is it? Right, let me just copy this example. I just want to double check if I understand this correctly. So, yeah, if I just do that, but if I do let input be this, and then I just do input, yeah, that passes. Okay, cool. So yeah, it's really just if you are using a literal, which means the incompatibility is basically like in the place where you're writing this thing, then you get an error. So okay, that makes sense. That's a very reasonable thing to check for. Okay. Right. Yeah, okay, so this is just what I just did. Okay, cool. L, okay, but this is very interesting. So even with optional properties, there needs to be something in common. Okay, what if I do... I guess this will fail, right? If I just do like an empty. It will not. Well, now I'm properly confused. What the heck? But if I do it the other way around, if I do input and this is empty, then it will fail? No. So empty is like a special case? What the hell? Oh jeez. Yeah, it is. Oh. Okay, that's properly annoying, I have to say. Like that's one, like I totally agree with the literals, everything, that's totally understandable. But this thing with empty is annoying. I mean, I understand why it's done that way, but then this check with like no common property is pretty weird. And I mean, I guess I can just do it as empty and this will pass. Yeah, it's lowercase, right? No. How do you do empty again? As this? Yeah, okay, now it passes. Okay, cool. Okay. I mean, no. This is kind of a nonsensical call anyway, but yeah, it's I don't know. I'm not quite sure how I feel about this particular case, but sure. Probably shouldn't be trying to get around these checks. Sure. Okay, so functions, very straightforward. Okay. Okay, yeah, makes sense. Yeah, okay, and name of parameters don't matter. Okay, makes sense. Corresponding parameter position. Right. Okay, but I suspect that this will, I mean, this will only work if the inferred types are actually matching with, you know, this expectation. Okay, sure. Right, okay. Makes sense. Mm-hmm. Okay. Right, so you can have an index of a type and it returns a type, but I wonder... So this is... I guess this covers arrays and dictionaries, right? But what, like, can you do like a tuple this way? Because that has an index of number, but the return type is like the union of all the things in the tuple. Yeah, okay, so index can only be string or a number. Okay. The type returned from a numeric indexer must be a subtype of the type returned from the string indexer. Interesting. Wait, what? All properties match their return type. This is because a string index declares that object.property is also available as object property. Oh, this is stupid. Oh, this is okay. Okay, now I get like this is JavaScript stuff, but sure. Okay, this is very silly. Yeah. Yeah, so like obviously very inherently, like if object.property also implies that object property is a thing, then oh, but it's very specifically for the string properties. So if this would be number, then it's fine because yeah, okay. Okay, we can, okay, sure. Yeah, okay, this is a little bit awkward, but yeah, I guess you can't really work around this because this is pure JavaScript. Yeah. Okay. Okay, so once we have an interface, we can create a class that implements that interface. Okay. This looks fairly standard. And actually, yeah, let's this thing with the string subscripts. It's definitely something that I want to note down. Okay, because object.property is also accessible through object property. String subscript operator needs to all properties of an interface need to match the return type of string subscript operator if one is present. Right? Yes. Okay. Yeah, that's definitely a quirk that I will run into at some point. I already see that happening. Okay, so then, yeah, this thing I wanted to just see. Yeah, I mean, I'm not really doing anything with it. So what's with the formatting? The formatting is weird. Let me just fix that quickly. Preferences, settings, text editor formatting. Sure, format on save, format on paste. Sure. Sure. TypeScript. Okay, yes, now on save it actually formats into something reasonable. Cool. Okay. Yeah, no, this kind of makes sense. Nothing super special happening here. Rather than both public and private. Not quite sure what they mean by this sentence, I have to say. Okay, I think now we are getting into the JavaScript side of things and I'm getting more and more confused. Ah, right. Okay. So wait, so in this case we create a function create clock that returns a clock interface. New okay, so we pass in the constructor, okay. So digital clock implements the clock interface. Okay, so this is a bit confusing. So, I mean, okay, so this interface is basically saying that we have a constructor of this type, which then use constructor yeah, it's slightly weird. I'm trying to think how this would look in C++ or Go. I mean, when it comes to factories, this almost feels like it's slightly upside down because the factory function kind of isn't the factory. Like the factory function is the generic part, which is, yeah, this is a very strange way to do it. Like you would, in Go and C++, like this would be a concrete function that wouldn't take this clock constructor. It would just return the clock interface, and you would have create digital clock, create analog clock. And because the signature of this function is the same, then you can use it. Yeah, it's really upside down. Like I'm it is a strange pattern, this. Yeah, very unusual, I have to say. Because I mean, the thing is, anyway, you kind of do that. Like you say create clock, digital clock. So wouldn't it be easier to just have create a digital clock? I mean, yeah, I don't know. It's a bit weird. I guess you are saving on having multiple of these functions, but yeah, like in C++ you would just make it a template. And okay, no, fair. Okay, yeah, that's kind of what would happen. So basically in C++ what you would kind of have is you would have like create clock, digital clock, and then the parameters, right? So okay, fair point. Like it's kind of doing this, but this digital clock is coming in as the first parameter. Okay, yeah, no, cool. Okay, I managed to wrap my head around this. Is to use class expressions. Okay. Const clock constructor. What the heck? Class clock implements clock interface. Okay, this is properly confusing. So I have clock two times. Like there's a clock that's a clock constructor. So I mean this is the factory thing, I guess, right? Then I have a clock class, which ends up being a local class because it's in this expression. Okay. Clock interface is this. Yeah, this is okay. Wow. What do they call it? Class expressions. Okay. Class expression Typescript. The class name is optional, and if specified, is only in scope in the class expression itself. Right. So I mean, it's basically an inline class, which makes sense. Okay, I'll just copy this and see. Right, so if I just get rid of this, so Uh, Okay, so this should print out 1020, right? I mean, it doesn't actually print out the numbers here. Okay, sure, whatever. Okay. Yeah, so I mean, so this is kind of the factory. Yeah, it's a it's a bit weird to me. Okay. Okay, so yeah, okay, sure. So class can implement an interface and shape interfaces can extend each other. Sure, makes sense. Yep, makes sense. Okay. Counter is a function. Wait, what? What the heck? I thought this syntax is that this interface contains a function with this signature. Function start number. Okay, this line I find super confusing. So first of all, where did the string go? And now the thing is, like, is this the body of the function or is this? Yeah, I have to admit I find this super confusing. Okay, so I guess this is a body. Okay. I think I get it. I'm still not sure where the string disappeared, because I would kind of expect that there needs to be a, like, you know, colon string over here for this to work. like let's just copy this example, right? So what I kind of would expect is that I need to have this here, right? Yeah, so I mean, exactly, this is a problem for me. So why is this okay? I would so if I would have this, right, return ABC, if I had it like this, I would actually understand this line. So basically saying, okay, I have a function, but let's look at the function as a counter, and the counter is a function and some extra stuff, right? So it's kind of like extends. Yeah, I don't know if you can even write that, but basically it extends this function, right? Like if you had an interface just for this function. And I think in a similar way, like if I do let x equals 10 as counter, this doesn't work. Is it just that it needs to be in the correct order? Okay, let me just test it. So, like now we are definitely getting into the interesting stuff. Okay, so let's just do interface x, right? So if I have, sure, interval number, right? And then whatever, the rest set can stay, that's fine, that's cool, right? So if I now do let x is 10 as x, okay, conversion of type number to type x may be a mistake because neither type sufficiently overlaps with the other. This is very interesting. Because I think this is what is happening. It's just that if I do it for a string or a number, it doesn't actually allow me to do that. Yeah, this is very interesting. Okay, if I do a number, b number, and if I over here do a 10 b 20 as x, this works. Okay. Well, this is an interesting quirk of this. Do they maybe mention this later? No, they don't. This is super interesting. I kind of understand why this is not working, but it looks like almost inconsistent to me. So what does this say? Convert the expression to unknown first, and this works. And then if I do console.log y.a, the heck? Okay. Yeah, I don't know what's wrong with my Spotify today, but somehow it's like refusing to stay in the same playlist for whatever reason. Okay, weird. Anyway, so this actually doesn't work. That's interesting. And if I do console.log x.a x.b, I suspect that this will work. Yeah, it does. And I think this will also work. Yeah. But it's so weird that this thing just works straight up. But yeah, maybe this is just JavaScript thing. Yeah. You know what? Let's just copy this link and let's just put it into the notes. Why is assignment of function as, what was it? As counter. Okay. But doing the same idea with a number or string does not work. Okay. Yeah, I'm definitely collecting a lot of questions and notes. That's for sure. Interfaces extending classes. Okay. Of the class, but not their implementation. It is as if the interface had. Okay. So classes can kind of work as interfaces in a sense. Wait, what? Okay. Button extends control, implements selectable control. So it has the oh, so it does have the state because it extends control and it implements. What? So what exactly does this do? Text box extends control, implements selectable control, image control incorrectly implements interface selectable control. Types have separate declarations of private property state. I'm not sure if I'm getting this. It inherits the members of the class, but not their implementations. This means that when you create an interface that extends a class with private or protected members, that interface type can only be implemented by that class or a subclass of it. Interesting. I'm kind of trying to think like yeah, I think this is just really useful for this use case when you have, you basically want to limit the interface to be only usable. Right, okay, so because, okay, right, so if you do this, then basically you end up with an interface that if you take it, if you consume it anywhere, right? Like you have a function that takes the interface as a parameter or whatever, then you know for sure that the thing you have gotten is inheriting from the base class. But when it comes to interfaces, that should be irrelevant. That's yeah, it's a weird thing to do. Okay. Like the kind of only example I can really think of is like if you are consuming the interface inside of this hierarchy, like these different objects can kind of talk to each other, and there's something that the base class provides, like I don't know, like there's a, let's say, some sort of ID or something in the base class that works in a very specific way, and you kind of don't want to get objects that implement that ID in a different way. It's kind of the example I can think of, but it's a bit weird. Yeah. Okay, functions. Most of the time. Okay, yeah, still plenty of time. Yeah, okay. So we can, yeah. In here we have a function add, and here we have a variable that basically has a lambda essentially. Sure. Okay. Okay, it says they capture these variables, but that has a particular meaning outside of, I mean, in C++ that means like a very specific thing. So I actually want to see what happens here. So add to Z, sure, 1, 2, but I mean, and yeah, welcome, first of all. Welcome, Sal. So my impressions are kind of mixed so far. I mean, the thing is, I used JavaScript like bits of pieces, kind of in the making websites context, but you don't really use the language that much in there. There is definitely a lot of weird stuff around. So this is TypeScript, and that's already trying to make JavaScript way more sane. But the weird parts of JavaScript are definitely peeking through, I have to say. It's like, while I do see, you know, like the parallels of most of the stuff in like C++ and Go and other languages, there are some weird things that definitely happen. Like I'm kind of keeping notes and like keeping open questions, and I already have quite a lot of things written down. But yeah, I mean, it's a language. Yeah, like that was actually one of my questions. How exactly does correlation work? But you know, this is my first episode of this, and I'm kind of hoping that over time I will kind of understand stuff. Right. Yeah, this was supposed to be append. Okay, so this is just my check if it actually works the way I would. Okay, actually, I was a bit wrong. Yeah, return Z. Okay, this is what I wanted to do. So rerun. Okay, so it's not really. Yeah, it's just weird formulation. Okay. It's just global variables. Like, there's no capturing happening here in the like C++ sense, or, you know, lambda sense. Yeah, I'm not quite sure why they use this formulation. Okay, thanks for the recommendation. I will definitely have a look at some point at like more in-depth stuff. Right. Let's add types to our simple examples from earlier. Okay, sure. Writing the function type. Yeah, okay, so the parameters returning type. Okay, makes perfect sense. Yeah, okay, sure, these don't matter, that makes sense. Right. Okay. Inferring the types. Ah, okay. Yeah, so I mean, depends on what you call complex. So C++ is a big language. I would never dispute that. But there's also the complexity that comes from like how vague the language is, I would say. Like, right? Like if you, I mean, now it's better, right? But early on, especially, like JavaScript was literally implementation defined because the actual JavaScript definition was like super short. It was like just, I don't know how many pages, but it was super short, like language definition. But that kind of leaves a lot of stuff for the people that actually implement it to just do whichever way you want. But that and that's a thing you also need to know. Like, it's not like if you write your code, like you will not run into that, you will run into that. Now it's better with, the ECMAScript standards, but I don't know, like a lot of the complexity of C++ kind of comes from the different layers, and you kind of have that in JavaScript as well. It's just like more, I guess, more from the way you use JavaScript. Like, there's a lot of things that work very weirdly in JavaScript. I mean, for example, if I just jump to my notes, right? I just run into this weird thing. So actually, let's just go back to that example, right? So there was this one, right? So you have an interface, right? The first property of that interface is a function. But somehow what you can do is you can take a function that doesn't even really match the interface because it's not returning a string. And you can type it to that interface and it works. Like, this thing just blows my mind. I really don't understand why this is okay. And there's like weird stuff like this all over the place. So yeah, I mean, I would almost go as far and say that, like, whether you find JavaScript or C++ more complicated, it kind of like speaks about the like way you think. Because I know there are definitely people that are very much okay with this like runtime fuzziness and not undefined things. I'm very much more like comfortable and less weirded out by things that are well defined, even though if the definitions are super complicated, right? Because for the most part I don't care, but like when I care I can just go and have a look at how exactly it's supposed to work, and it's very easy to look up, right? But I know people that are very much comfortable with this kind of like complexity that comes from like the dynamisms of the environments and everything. So, depends on what kind of person you are, I would say. Okay. Where was I? I don't even remember. Yes, okay. Default parameters, okay. Okay, so we can have basically an optional. Yeah, so we are back to this thing that I was kind of curious about last time. Yeah, so it's an optional parameter, and yeah, I guess we check if it's undefined. I really think that that's what the equivalent expression here is. But yeah, I will need to look it up somewhere. Last name. Okay, so wait, so this is an optional parameter. Where was it? So this is an optional parameter, but I can also have default parameters. Okay, that's reasonable. Default initialized parameters that come after all required parameters are treated as optional. I mean, really, like when it comes to C++ versus other languages, I would say that it's definitely easier to jump into a scripted language, whether it's JavaScript or Python or whatever. But honestly, if you tell me to make a piece of software, if the software is big enough and none of the languages are like either optimized for that use case or like antagonistic to the use case, right? Like there are definitely some cases where like, okay, like you definitely shouldn't write, I don't know, like your server application in, now I cannot think about anything, but you know, there are definitely some languages that are like super specific to making like desktop applications, for example, or super specific to making servers or processing text, or you know, there's like these like domain specific things. But if you take like the general languages, the code, like the complexity, overall complexity of the code and everything will look quite similar. Like the verbosity of the language might differ, but ultimately all of it will look very similar, because if you are building something that's like big enough in the scale, what takes over is the architecture, because you still need to provide the same functionality and everything, and the thing that starts overtaking and driving the code is the architecture of the entire thing. And you might, of course, you know, in JavaScript, because there's all of these like single thread issues and whatnot, you might end up with some problems that you don't end up in C++, because C++ is, you know, optimized for doing multi-threading and super high performance code and whatnot. So some languages might skew you to like a different architecture, but if you would just, you know, kind of say, okay, like I'm doing this thing in this architecture, like all the languages kind of end up being just syntax, minus, you know, the hard details, like, you know, the single-threaded nature of JavaScript, for example. But yeah, I mean, if you know, people kind of freak out about languages early on in their careers. Once you write enough of code, it's like it's impossible to stay within one language. Well, it's not impossible. There are definitely industries where you can definitely stick within one language, but it's unusual to kind of only stay working in a single language. And once you kind of try writing stuff in multiple languages, it's similar to, like, you know, human languages. Like once you know enough of them, like the grammars are similar, you know, in the different classes of languages. You kind of start seeing the meta patterns and whatnot. Yeah, I mean, yes. So that, yes, I know. There are ways to work around the limitations. Yes. But yeah, I mean, in my current point in my career, I very much just see languages as, you know, it has some quirks that I need to work around. It has a slightly different syntax. And other than that, eh. I still have like preferences for particular languages. Oh, this is interesting. This is something like, this is definitely a query that is quite unusual in like statically typed languages, because those kind of force you to have default parameters at the end. So you cannot have like default parameter here and you just pass undefined in there. That's just not the thing. Okay. Okay. Okay, but I assume this needs to be of the same type then. You cannot have like a tuple here, I guess. Boundless number of option parameters. It will build an array, so it has to be the same type. Okay. Yeah, so it literally works as an array. Okay, cool. No, that makes sense. Okay, we have reached the mystical this. Okay. Okay, this is getting a bit weird. It's a variable that's set when a function is called. Interesting. So, okay, so what's happening here? So there is a create card picker, which is a function that returns a function. Okay. And the function that returns picks a card, picks a suit, Okay. So system programming is a lot of fun, but it is becoming a very narrow field, because what has kind of been happening over time is like you get these very specialized tools and systems that kind of hide the complexity from you. And these are the things where people need the system programming. But if you are building, I don't know, a website or streaming service or whatever, right? When you're building this like distributed system that's relatively complicated, let's say 5 years ago, definitely 10 years ago, you would do a lot of system programming. What you do these days is you just pick a database, you pick maybe a queuing system or like a communication protocol or something, and those are all like ready-made libraries. And you can just do all your like business logic in a very high-level language, because you kind of have chucked all the complexity into these components that you just start and run. So it's definitely like it's becoming even more important, because these components need to be like top-notch, right? But it's becoming a very narrow field, which well, okay, is developing for web unavoidable? Depends how you define web. So okay, there are definitely industries where you don't run into that, right? But it's less and less. So, for example, game programming, right? There is like on the engine side, you have a lot of system programming there, but it's a big industry. But again, the engines are a very small part of the industry. And outside of these like very specific situations, everything is online, everything is web. So, I mean, it really depends how you define web. Like if you are just talking about, I don't know, like, online stores and websites, then sure, you can avoid that easily, right? But like, everything is kind of connected these days. Everything is on the web somehow, in some form. So yeah, it is kind of unavoidable at this point. Like if you specifically don't want to deal with just like HTML, probably not a big deal. You might still run into HTTP, because that's kind of the protocol of choice, even for like two, sensors talking to each other. Yeah, but I mean, okay, so like multiplayer games are not necessarily web, because you have these like very specific, like very industry specific protocols, and even like game engine specific protocols that these games use to like kind of talk to each other. So that's not necessarily web, that's like a very specialized thing. But I'm more talking about like, even if you, okay, let's say you have like a temperature sensor, like Internet of Things, right? Like you have these tiny chips that are just like, connected to the web app or somewhere. I mean, they're properly using HTTP. They might even be running some web servers so people can like connect to the thing and look at what's like the current situation or status. So that's more where it kind of leaks through, and you have web programming even in areas where you wouldn't necessarily expect it to be. It's definitely a thing that happened over the last 5 years, for sure. Like, it's kind of these, you know, if you kind of want to see what's the norm these days, look at like what were the buzzwords like 10 years ago. Oh, no, that's the... I don't want to overwrite my readme here. Okay. So we are returning an object here. Okay, that's just object that just has a suit and a card. So with game dev, I mean, you have crunch in a lot of places. It's not just game dev. The reason why people are kind of hearing about that is because they kind of took it to the next level in some of the studios. And then you kind of have this, and it's the counterpoint of you are creating a product that people kind of love and kind of use for, you know, relaxation, but the people that work on that are kind of, you know, being burned out and having mental issues and committing suicides and whatnot. So I think that's why it's kind of well known that it's a thing. But crunch time, you have it everywhere, unless like the company is explicit about that this is not a thing. And there are some countries that are very strict on like the amount of overtime you can have. So it's really depends, and it's definitely not specific to game dev. But one thing I like, the thing I would say about game development is that these days there is very little development to be done. Because like the thing I mentioned with, you know, building these distributed systems where you just pick a database, pick a communication library and whatnot, that's even more true for game dev. Like game dev these days, like especially for a small team, it's very much just game design. Like there is very little actual programming happening. Because why would you do that? Like you just pick an engine, and sure, you like, you know, you need to implement like the behaviors of things and whatnot, but there's no like low-level programming necessarily. And sure, you can go the route of making an engine, but then, I mean, at that point you are really putting yourself into like into a detrimental situation because you are doing work that's unnecessary. So unless you are doing it for fun, it's a weird thing to do. Or not just fun, right? Like unless you are doing it for fun or for like learning things. Okay. Cannot read property free of undefined. Where is that happening? This suite's big suite. Okay, so the big suite is the free. How hard is it to implement physics engine? Oh boy. To be fair, I'm actually not aware of like a full-blown physics engine. In the context of like games, it's always very specific. Like you have like engine for like physics engine for like clothes simulation, like how clothes move on people. You have engine for like simulating hair, for simulating water. So you have these like very specific pieces. I'm not really aware of anything that's like full-blown, because those tend to be like incredibly slow, and you only find them in like specific software that does like, I don't know, that's usually used for like, I don't know, designing cars and airplanes and whatnot. There you get like the full-blown physics engines that have, you know, the like proper simulation of the air patterns, and they have like they basically simulate the particles essentially, right? And they need to be super precise, so they have like proper physics engines. But in games you usually get like very specific stuff. That's why it's always like, you know, when the, what was it, the NVIDIA, there's like the hair technology in NVIDIA, I don't remember what the hell is it. I think you need, so, okay. It changed, right? Like, because things moved into engines. But like graphics and physics, that's all pretty hardcore math. And even 2D, like even doing like a blur, like that's like matrix multiplications and like not easy stuff for sure. So, you know, it depends. Like, I think these days you can literally build a game, even like a AAA proper game, with basically doing almost zero coding. Like you will definitely need to code something, right? Like there will be some sort of scripting happening for sure. But that's the level of coding you will do. It will be just scripting, you know, the quests and whatnot, like, you know, basically sequence of things happens, like basically decision trees, right? Like, oh, if the player chooses to do A, then, you know, something happens in the world and whatnot. That's the level of programming you would do. And again, like you can go deeper, and especially like, you know, there are still companies like CD Projekt, right? Like they have their own engine. The same for Paradox Interactive. They have their own engine, which kind of gives them the ability to do weird things with it. But you don't have to do that. And, you know, probably if like Witcher wouldn't be Witcher if they didn't like use their own engine, right? And they wouldn't be able to port it to Nintendo Switch, which they did. But you can make a game like Witcher, and there are games like Witcher. Okay. So back to this example. I think what they're trying to demonstrate is that this actually referred to here. Yeah, because that's the context of this function. Actually, maybe, wait, no. So this actually returns a function. So that's actually not even executed here. That's actually executed here, right? Oh, WebAssembly. So go check out my other project, because yes, I did try WebAssembly. So this is all C++. It's a Sudoku solver that runs in the browser. There's no backend or anything. Oops. Yeah, the UI isn't the best. Because I'm definitely not great at making, you know, good UIs. But yeah, it's a working solver. And all of this is just C++, cross-compiled into WebAssembly, running in your browser. There's like one line of JavaScript that I had to write to kind of hook up to a global event, because that wasn't like exposed in the WebAssembly. But yeah, that's kind of it. Like all of this is C++. The only reason why I'm actually doing JavaScript now is because specifically I needed OAuth, and literally couldn't find an OAuth library for C++. The libraries I found either didn't work or had limitations that basically made them useless to me. Okay. Okay. Yeah, so you know, I basically stream every weekend, some sort of thing. The Sudoku solver is my first project. I've streamed that one for quite a few weekends already. I think I'm at like episode 40 or something crazy like that. I don't remember. Then my second project is a chatbot, and that's when I actually run into the limitations of C++. So I started looking into the JavaScript to kind of do the, you know, OAuth and HTTP client stuff. Okay, no implicit this. Sure, that's something I would definitely like to turn on. No implicit this. True. Yep. So okay, if I go back to the function, terminated. Oops. Yeah, this implicitly has type any. Okay, perfect. Now it is returning error. Cool. So I was really considering either going Golang or JavaScript. I settled on JavaScript because, first of all, Golang isn't scripted, and I kind of don't have a scripted language in my arsenal right now. And kind of the reason why I'm doing these streams is to actually learn stuff. So that's kind of the two main reasons why not Golang. And I already know Go for the most part. I worked at Google, and the Go is definitely I don't know if I would say a preferred language, but it's definitely a language that people kind of would like you to write code in. Let's just put it that way. So yeah, that's kind of why. The thing is, like, if I knew Python, I would probably use Python, but Python is like a language that like completely missed me, because at that point I was deep in C++ when it kind of took off. And I was never fond of the syntax, I have to say, which, you know, not an amazing reason to pick languages, but it is what it is. Okay, so we have a card interface that has a suit and a number. Sure, makes sense. A deck has suits and has cards. Which I mean, sure, that's a, yeah, this is bit of a weird interface, honestly. I guess I wouldn't call these cards, I would call it like value or something, right? Because it's not, we don't have 52 of the cards, I don't think, at least. That's no, we do, wait. Or we just pick the suit by dividing by 4, dividing by 13, so we get... Okay, sure. Yeah, this interface is a bit weird. I wouldn't make it like this, but sure. It works, kind of. Okay, so then we have a deck, which is of type deck, sure. We have the suits, we have the cards, we have the picker that actually returns the function. Sure, okay. Okay. Okay, so if you say this void okay, so you can basically annotate Wait, what? Ah, right. Okay, now I get what I mean. Sure. So yeah, okay. So here we are saying that our this is of type handler, but the callback doesn't provide this. Okay. Sure. Yeah. Okay. No, I get it. Mm-hmm. Okay, and we need to use the arrow function if you want to basically capture the look with this. Okay, sure. Okay, yeah, okay, this is definitely weird in JavaScript, I have to say. That's like... if you use this syntax, it's this. If you use that syntax, it's that. It's still this, but it's different things. Overloads. Okay. I mean, okay, that I kind of understand. Oh wait, interesting. Oh, so you can basically make like list of overloads. Yeah, I did not know that this exists. This is neat. So, I mean, okay, I guess I don't have to use this kind of complicated example. So let's just do something simple, right? So let's have our actual function, right? So if it's a number, then just print out, you know, it's a number. And if it's string, sure. Okay, let's just test if this works. So test 10 should print out it's a number, and test ABC should print out that it's a string. Let's do that. Maybe not. What just happened? I thought this checks for the type. Oh, type of, yes, right. Indeed, that's correct. Thank you for that. Yep, okay. Okay, but if I do test I guess false, right? So this would be neither of these. So this will now fail. I mean, this would not fail. Okay, yeah, just not print out anything, right? But if I do function, and I guess sure, let's just return vs number and return vs string over here, return undefined otherwise, right? So right, well, let's just double check if this works. Yep, that works fine. So what the TypeScript thing was saying, I can just provide if you send 10 as string, yes, because that's checking the, because 2 equals will check the value, not the value and type, right? Yeah, okay. Yeah, so now I cannot call it with the boolean because it doesn't match any of these. So what I can do is test v boolean and it returns undefined, right? Now this will work again. Okay, cool. Now this all makes perfect sense. Okay, retro types. Okay. Wait, what? String return types combine nicely with union types, type guards, and type aliases. Oh. So is this just defining types that are named isin, isout, and isinout? I mean, this is almost like a string enum. Interesting. Right, it's this thing. Yeah, I don't know. I mean, it So it totally makes sense. Like JavaScript is the new Java. So the reason why Java was popular was because it was easy to write in. So there was basically a big pool of developers, software developers. So if you kind of want to hire, at scale, you write your stuff in Java. And JavaScript is kind of the new Java these days. Basically, if you want to never run into issues with hiring people, you basically always have people to pick from, make your software in JavaScript. it's what it is. Like finding good C++ developers, that's hard. Finding, good JavaScript developers, you have a much bigger pool of people. This is interesting. It's like string tags. Okay, this is very interesting. I have to say, I kind of find this quite amusing because it's like the string variant is very this is very JavaScript, but this one this is it's almost like bit fields in C++. I mean, this is almost in enum, but you don't get the descriptions, I guess. Well, optimizing things makes sense sometimes. The thing is, people were complaining about browsers being slow and basically websites being super heavy. And that was on the level of having one tab open. This was back in the times where you didn't have tabs. These days, people have 50 to 100 tabs open at the same time. Things change, and I mean, especially when it comes to memory. I mean, it's not like we had super high pressure to increase the memory capacity in our computers lately. People are still running with 8 gigabytes of memory, which I find crazy. I have been running 64 gigabytes for ages now. My last 3 computers had 64 gigs, and that's what, 12 years almost, maybe? That's insane. But yeah, I mean, you can totally even top-end games these days, you can still be totally fine with 16 gigabytes of memory, no issues at all. So I don't know, it's not really something that's, I would say, is a big deal. and you can run like in, you know, on desktop hardware you can easily run like what, 256 gigs, maybe half a terabyte. On servers you can easily run multiple terabytes of memory without any issues. Yeah, my current PC is fast-ish. One thing I'm not super happy about, it only has a gigabit network, which is actually limiting me right now because I have the one of the like disk arrays, the external ones. I have the what is it? Can I actually? System? Yes. Right, let me just check if there is something. Yeah, whatever. Okay, I will not show it because I'm actually not sure if some of these numbers are like interesting. But I have the i7 9700K, which is like the second from the top from the previous generation of Intels. 64 gigs of memory, 2080 Ti. I have a bunch of different drives in this computer. I have like two at the, what the hell is the name of that? Now it completely escaped my mind, but like the SSDs that you plug into your motherboard. I have two of those. I have two like SATA SSDs. I have one like spinning drive that's like big one at 12 terabytes or something. I have a sound card, which is a weird thing. Most people these days don't use like an external like a proper sound card. What else do I actually have there? I know that I have like all the slots full, which is one of the annoying parts. Yeah, it's because I use it for both for work and fun, it kind of ends up being kind of crazy. Yeah, I mean, what I'm waiting on actually with the upgrade is I'm waiting for AMD to announce the new CPUs. So I will definitely be going for a high core count CPU and probably a 3090. The thing is, looking at the benchmarks, I might not benefit from the 3090. Like in games, it's like 5 to 15% extra, which like for the money you are paying is very meh. And for productivity, it's definitely a big win, because in certain apps it's definitely even better than the last generation Titan by like 2x, 3x. But it's like very specific things. I would definitely like having like faster video encoding, because when I do like, you know, video editing, the time it takes to like create the proxies and then actually generate the final video, it's super annoyingly long. But I like the benchmarks actually not really showing any like improvement over the 3080, so we'll see. It's more the CPU that's kind of right now kind of giving me a hard time, but I did actually upgrade to this one recently, so well, yes and no. It is, but in very specific situations. like it's definitely, so the 2080 Ti for like RTX gaming was like the only card that was actually usable, and it was struggling. The 3080 is definitely usable for RTX workloads, like, you know, reflections and ray tracing. So for that, sure, but it's still a new technology, and the games, like there are some show PCs like the Minecraft thing and the Quake remade in RTX, but like the actual utilization in games is not that impressive. Like you are not losing that much if you don't use RTX technology. Like the big thing for the previous generation of NVIDIA's was actually, at least for me, the new NVENC encoder, because the quality of that one is just really good. Well, since I have a PC, Xbox is like completely redundant because all the games that are on Xbox will be on PC. Even the Game Pass is available on PC. So there's like, if you have a PC that's like not just like a web browser thing, like if you have a notebook that's just like a Chromebook or something, then sure, but like otherwise, why would you ever buy an Xbox as a person that has a PC? That's like a really redundant purchase. PS5, I don't know. I have a PS4, but honestly, like the last 2 years, maybe, it was either PC or Switch, and I haven't touched my PlayStation at all. Okay, take a string and it's padding to the left. If padding is a string, then padding is appended to the left side. Then the number of space is added to the left side. Wait, if padding is a number... Ah, right. It's typed and it means you can call it with an argument that's neither a number nor a string, but Typescript will be okay with it, sure. Abstract to two types, creating hierarchy of types. I don't know, like I think the combat in those games are a little bit too unresponsive for me. Like I kind of, when it comes to these kind of like hack and slashy style things, although like I know Bloodborne isn't really hack and slash, but it's kind of, you know, it's in that ballpark. I kind of want the combat to be like hyper responsive. I don't really like where you need to like commit into an attack and it's like a slow attack and you cannot really interrupt the animation. Yeah, I don't know. It's I did really enjoy Witcher, playing it on like the hardest difficulty, where basically if you fight against like a higher level enemy, like one hit and you are done basically. But I mean, even that was frustrating from time to time. So I don't know. And like Witcher is very arcadey in that sense. Okay, so yeah, okay, so this makes sense. Unions with common fields. Ah, okay, interesting. Discriminating unions. Ah, okay. Okay, so so this is the weird like type narrowing happening. So when you have a union of types, you can only access the shared state by doing no checks. Sure, makes sense. But then once you start narrowing it down, you basically can access anything, like whatever is in that particular situation available. Okay, makes sense. Function lacks ending return statement. A return type does not include undefined. Interesting. So it can actually check. Wow, this is actually impressive. So it basically it can figure out if for all the subtypes in the union there is actually a valid return. I wonder how complicated this code can be. Like if it's just on a switch, or you can have like more complicated code with like bunch of ifs and whatnot. But that's actually impressive. Okay, and sure. I think I actually have this turned on already. Yeah, I do. Cool. Assert never. Oh, okay. So if you don't want to turn on strict now checks, you can do it through basically this situation where you have a default branch and yeah. Sure. Intersection types. Okay, so this is almost like mixins, right? You basically can create things and then just slap them together. Okay. Okay. How far am I? Oh wow. Okay. I'm getting to the end. I still have enums and generics. After the classes. Sure. And actually, what's the time? It's really hard to see. Okay. Okay. Nothing super surprising so far. Okay, we have a distance in meters. Dog extends animal. So modules have been added in C++ 20. I don't think... Okay, let me actually check, because there was a GCC 10 or 11. There was a recent compiler release. Was it not GCC? Anyway, so the C++ 20 standard is not yet implemented by all the compilers, but it's part of the standard. The tricky part there is, though, that for modules to work properly, you also need support from the build systems, which is like essentially like if you have a project in your IDE, like your IDE also needs to support modules. And I think Visual Studio already does somehow. I think the Visual Studio has some sort of module implementation, but it will take a bit of time, like for all things to kind of catch up. And there's like a way to kind of use the old headers as modules, and there will be this like interim period where everything is kind of a little bit messy, for sure. But yeah, hopefully we will have proper clean modules, and it will definitely be a big jump for C++, because the current situation with headers and everything is just, it's such an outdated and archaic model that it's just ridiculous that we are still using it. Yeah. If you just search for module C++, you should be able to find how exactly it will work. Although I think like the most articles we will find about how exactly to make it backwards compatible. So okay, inheritance is just extends, sure. Okay, more complex example. So we have an animal that has a move. We have a snake that has a different move, okay. Which must call super... Okay. So if you are writing a constructor in the derived class, you need to call the original constructor, sure. And overriding methods. Okay, perfect. This all makes perfect sense. Public, private, protected. So public is default. Oh, and you write it with each property. Okay, sure. Oh, so you can do hash name for private stuff. Okay. Sure. And then there's TypeScript private. Ah, okay. So this one is like JavaScript level private. Sure. And if you write private, it's just TypeScript level. Okay. No, makes sense. But that should be fine. I mean, what would be the situation where, like, since TypeScript is strongly typed anyway, like, you shouldn't have a situation where you can get at a private member. It would have to be some sort of dynamic typing situation where you have an object that's like either any or like one of those unions, and you somehow get at... Yeah, I cannot really think about the situation, because like you would have to work around TypeScript. But I guess yes, like this one is more enforcing, because this will be enforced on a JavaScript level. Yeah, I mean, this happens when you kind of reintroduce things into language that kind of the language wasn't built for. Like JavaScript wasn't really built for classes either. Like it's all of this is kind of, you know, built on top stuff that was just weird from the start. Oh, wait a second. So employee it's not assignable to type animal. Wait, what a second. This is weird. Ah, yeah, okay. So this comes from the... Damn it. Okay, this will be... This will keep screwing me up. I already know that. Because this is not how classes work in other languages. Like, this is wrong because employee has a private property that's not compatible with animal. But the thing is, like, in a normal strongly typed language, this would fail anyway, because these two types are completely unrelated. Like, why would you be able to assign these two, like, to each other? That doesn't make any sense. Yeah, okay. Okay, and protected works as you would expect, sure. Can use the name, sure. Yeah, okay, read-only modifier. Yep. It's again, yeah, it needs to be set in the constructor, sure, works. Parameter properties. It's needed in order to have value the name. Ah, okay, so okay, so you can initialize it basically inline. You know, am I misunderstanding that? Name and the constructor parameter the name in order to have a value of the name accessible in the octopus constructor. Mm. Okay, I don't quite get what they are trying to say here. They're talking about this name, so we had to declare a read-only member name and a constructor parameter the name in the octopus class. Okay. So if you are, okay, I get it. If you are getting the parameter in the constructor, you can basically create it and have it initialized by the caller. Okay, no, I get it. Books on system design. It's a hard question. Honestly, these days, I wouldn't really recommend books. Like, that sounds like a blasphemy, but the thing is, like, there are still these foundational books, like, you know, the, what is it called? Art of Programming. Like, the very, like, you know, the book about algorithms and, like, the very, like, very core things. But the problem is, the industry is moving so fast, like even books on C++, because the language keeps evolving now, it's like the books just get invalidated the next year, essentially. And it takes time for a book to be written and published, so either the book has like stuff that, you know, is not really super in sync with what actually ended up happening, because it was basically published before the thing was actually, like, you know, completely ironed out, or when it comes out, it's almost already out of date, because like you are getting the new standard very soon after that. So I mean, I don't know, I really don't have like any good books on that. Like there's the books that Google published, they have things on, I actually have them right, I'm actually looking at them, they're right in front of me. So there's like the site reliability engineering and software engineering at Google. Those are much more like how we do things books, not really like they're like they have, like, especially the site engineering stuff has like system design stuff in it, but it's not a book on system design. It's like kind of as a, you know, as a side thing to how we do things, is also how we design systems. So yeah, I mean, those are kind of okay to read. Books on programming in general. I also don't quite know if I would. It depends, right? Like there's, again, like depending on what you are really interested in, there's these foundational books. Like there's the what the hell is the book called? I think I also have it in my bookshelf somewhere, but is it this one? No. Damn it. There's like a very foundational book on algorithms. And right now, for the love of me, I can't. Oh, is it this one? Yeah, I think it's actually this one. Okay. Yeah, okay, yeah, it's this one. Like, this is something that's kind of worthwhile reading. I don't know if it's worthwhile reading end to end. But it's definitely... like, you should know the things that are in this book. Let's just put it that way. But again, like, I honestly don't think reading books these days is a good spend of your time, especially when it comes to programming. Like, you should kind of... book are great references, so like when I and that's what I would use these type of books for. It's kind of like when you want to look up something specific, but then again, like, most of the content of this is anyway on Wikipedia. Like, you know, if I go, you know, merge sort, right, there's like a pretty long article about merge sort with like examples of code and whatnot. And you know, you can always down here go to the references and then look up the specific, you know, links. And I mean, you know, this is just the section of sorting algorithms. So because we kind of have Wikipedia, could be, I don't actually know, honestly. It's like, it's one of those like very foundational books, and then there's a couple of these, but again, like, there's like this set of things you should know or at least be aware of, but then honestly you can find all of this stuff on Wikipedia. And the articles about like the very foundational stuff on Wikipedia actually tend to be quite good. So yeah, I don't know if I would recommend books specifically. I would definitely recommend practicing this stuff. Like, you know, if you are not that familiar with like sorting algorithms, you should definitely implement sorting, like the basic sorting algorithms yourself. At least, you know, quick sort, merge sort, bubble sort, of course, that one is easy. But, you know, like, just implement the basic sorting algorithms yourself. Maybe just learn how to benchmark the algorithms as well and compare them against the standard library and see how well you did. And trust me, like, you will be nowhere close, but it's good to kind of get the gauge of, okay, like, you know, you didn't completely screw up the implementation and it's not like quadratic or something out of nowhere. That's kind of the stuff I would do, and that goes for like all these kind of things, like, you know. And then maybe read, you know, the books from Google, because they are very much like how we do things in practice kind of books. And that information is kind of locked inside of Google, so it's kind of good, you know, it's not easy to get at that information. So the only way you can actually learn about how Google runs their systems is to actually read those books. So that's why those books are worthwhile, because it's a very locked up knowledge. Or also you can watch, like, you know, like for CPP, this channel. And right now they're actually uploading videos from CPPCon 2020. Probably not worthwhile to watch all of this stuff, but they have a lot of, like, you know, even like introductory things, like for example, back to the basics, you know, template metaprogramming and whatnot. You know, there's a lot of good topics here to watch, and many of the like old talks as well are still very much valid. Like talks from 2 years, 3 years, 4 years are still like completely valid talks and good stuff. When it comes to the hardest algorithm I had to implement, man, that's a hard question. That's like maybe quick select, but that one isn't like, it's not an algorithm that's like super complex, it's just like very confusing. And also it wasn't really something I had to implement, it was just like I did it just for fun. There was a lot of like things that had many layers. Like in 2 jobs back I was doing a lot of job scheduling and it had a lot of like weird things in there. But mainly because that was an actual research, so you kind of had to do things that, you know, no one did before you, so you kind of need to go through the entire process of like measure things, you know, try to think of potential improvements, then try them, fail, and try again. Okay. Okay, that's just accessories, sure, that all. Oh, wait a second. Oh, so this actually maps to the... Ah, okay. So these are actually like transparent accessors. That's cool. Get set. Okay, sure. Static properties. Yeah, I don't have too much time. I do watch some people from time to time to kind of see what they are doing on Twitch. But yeah, I honestly, like, I do have a full-time job, and with that and doing live streams myself, it's kind of hard to find the time. Constructor functions. Okay. Okay, the classes all seem kind of pretty standard stuff. There are a couple of things here, right? There's the get set, which is not really something that you have in C++. And yeah, the private stuff works a little bit weird. Yeah, so I do actually plan to make a C++ course, but it's not coming anytime soon. So I do actually plan to work on it during the winter vacation. So it will start coming out sometime in January. But yeah, it will be like a proper end-to-end C++ course, all just on YouTube. Because I did actually teach C++, like, what was at this point it's like 5 years ago when I stopped. No, actually more. Yeah, like 6 years ago. And I do kind of miss it. And lots of stuff happened, of course, because that's literally like all the new standards kind of came up in during that time. So C++ moved a lot. But yeah. And it will be like a very from basics to up to, you know, creating a proper project with a nice end result. That's kind of the idea. Okay, how much more text is here? Okay, I kind of feel like I will leave the enums and generics because I feel like the generics will be probably big amount of text. Okay, sure. I will actually leave it for tomorrow. Because yeah, I've been streaming for a while and my voice is starting to die slowly and I'm also hungry. So yeah, it's time to finish this stream for today. So thanks a lot, Sal, for hanging out. It has been fun. I do stream every Saturday and Sunday, just FYI. And I will be back tomorrow at the same time. So starting 2:30 p.m. Central European time and then going usually for like these 4 hours. That's kind of my usual, you know, endurance, let's just say. Yeah, we will hopefully finish the TypeScript. I still have the enums and the generics to go through. And once that is done, it will be time to start, you know, doing some coding to kind of ingrain these ideas in my head. So yeah, thanks again for watching, thanks again for hanging out, and see you tomorrow or some other weekend.